All right, this is a video for geometry on area of parallelograms and rectangles. We'll start off with a brief overview, a couple of formulas, and then we'll do a few solved examples. So the area formulas for rectangle, parallelogram, and triangle are as follows. The area of a rectangle and a parallelogram have the same formula. Area is going to be base times height. Okay, and that'll give you the formula for any sort of a parallelogram. That includes a rhombus, a square, a rectangle, or just a generic parallelogram. What's important to keep in mind is that base and height must be perpendicular. Okay, so for example, it's in this rectangle, I think it's easy to see that the height is the vertical side and the base is the horizontal side. But in the parallelogram, what I'm highlighting here in red is not the height. Okay, that's called the slant height, but it's not the height that we want to use in the area formula. So we would use this as the height, and it would be perpendicular to the base. In the area of a triangle, the formula for the area of a triangle is simply 1/2 times the base times the height. Students often ask me, is it half of the base times the height or half of the base times height? Those are the same things, okay? So you're welcome to do 1/2 of the base and then multiply by the height, or you could do base times height and then multiply by 1/2 or divide by 2. Okay, same deal. And as we said earlier with the parallelogram, the height needs to be perpendicular to the base, okay? The other thing to keep in mind though with a triangle, and as well with parallelograms and rectangles, the orientation of the shape should not change the area of the shape. So let's try to work with this triangle here. Let's imagine that the triangle was just in a different orientation, okay? And what if let me try to rotate it here. What if the triangle looked like that? Okay. This would be the base, and the height would actually fall outside of the triangle. That's called the altitude of a triangle, and the height is technically the length of the altitude. And this height or this altitude would need to be perpendicular. It wouldn't intersect the base, but it would intersect the line that contains the base. So just keep that in mind. The orientation of the shape should not change the area, as I think you understand, but we would be using a slightly different process to get there. All right, let's apply this and find the area of a parallelogram. Couple examples here. And for both of these examples, I think you can see that we're given information we won't need. Okay, so those slant heights are not going to be applied here. So for the area of this top parallelogram, area is simply going to be the base of 5 times the height of 4, which is 20 inches squared, or 20 square inches. And for the bottom parallelogram, area is going to be the base of 2 times the height of 3.5, and that's going to be 7 square centimeters. Okay, so again, just a reminder that the height can fall outside of the actual shape. All right, this next one is finding the missing dimension. We're looking for this height that I'm highlighting in red. We're wondering what that dimension would be. We can call that x, for example. Okay, and the thing to keep in mind is for this, we're going to find the area of the shape in 2 different ways. So first, what I want to try to do is rotate this so that the base and the height sort of conform to our expectations of the base being on the bottom and the height being a vertical line. So we can say that here that the base is 13 and the height is 9. So we can find the area of this parallelogram is 13 times 9, which is 117 square inches. Okay, and now if we rotate this shape back, we can say that 117 square inches should be 9.4 times the height of x. Okay, so 9.4x should be 117. Okay, it's the same shape. The area didn't change just because we rotated it. Let's divide both sides by 9.4. and these 9.4s cancel, and we're left with x is equal to 12.45. I'll round to 2 decimal places, and that would be 12.45 inches. Okay, so that would be the missing height right there. Okay, a little bit of a real world problem, might seem a little bit contrived, but I think it's got a little bit of good math in there that I want to look at. So we have a triangular sail on a sailboat here. We know the base is 13 feet 4 inches and the height is 12 feet 2 inches. What's the area of that sail? Here is a very common mistake. It's a mistake to say that the area is 13.4. Well, let me actually throw in the 1/2 first. Remember, area is 1/2 base times height. 1/2 times 13.4 times 12.2. Maybe do a little bit of thinking about what is the mistake. The mistake is, and I'll cross that off so we remember that that's a mistake, 13 feet 4 inches is not 13.4. Okay, so the area will be 1/2 times 13 and 4/12 times 12 and 2/12. Okay, obviously 12 inches in a foot is where those came from. And so we can turn this into 1/2 times 13.4/12 is 3 repeating, and then 2/12 is 1/6. So that's 13, let me write that a little bit cleaner, 13.16 repeating. Okay, so now we can go to our calculator and type those numbers in, and let's see what we get. And I'm going to get 81.1 repeating, or 81 1/9, and that's going to be square feet, not square inches, square feet. We're working with units of feet. Okay, so either one of those would be legitimate answers. Lastly, we're going to look at the area of a composite figure. Composite means a couple simpler shapes joined together or merged together to form a more complex shape. So here's a composite figure. It looks like we have a triangle. Looks like it could be isosceles. We don't know for sure, but that is sort of superimposed or added onto a square. So there is no formula for this. We just need to find the individual shapes. And you will eventually be encountering relatively complicated composite shapes. And I think the most important thing is just to stay organized and just keep track of all your work. Don't try to do too much in your head, etc. We know that opposite sides of a square are congruent, so that's going to be a base of 6. So the triangle has an area of 1/2 times 6 times 8, and the square has an area of just base times height, which is 6 times 6. So 1/2 6 times 8 is 24 square inches, plus another 36 square inches, and those added together will give us a total of 60 square inches. That would be the area of that composite shape. Just keep track of your shapes, and you should be fine. All right, area of rectangles and parallelograms and triangles. We got through it, and that's a good place to stop right there.